We will be tackling another graphing calculator question today. A particle moves in a straight line its displacement s meters from a fixed point p at time t seconds given by the line s of t is equal to 3t plus 2 to the power of cos t, for 0 is less than equal to t is less than equal to 6.8, shown in this graph over here. This is a 5-part question. The first part, we want to find the particle's initial displacement from the point P. So our initial displacement will be right over here. First, let's graph our line. So y1, which is our displacement, our s of t, is 3, and we'll replace this with x. We'll replace the t with x just to make it easier in the graphing calculator. So 3x plus 2, all to the power of cos x, and we will graph this. We get this line over here, which is very similar to what we have in our question. So we want to find when x is equal to 0, or when time is equal to 0 right over here. So s of 0 is equal to, we can click trace on our graphing calculator and type 0. So when we look for x is equal to 0, y is equal to 6. So s of 0, we have 6 meters. Awesome. So the next question, find the particle's velocity when t is equal to 2. So when we see velocity, this is different than our displacement line. Our velocity, v of t, is the same thing as the derivative of our displacement, or s prime of t. So let's make a new line. Our y2 will be our velocity line. To get the derivative, we'll click math. We'll look for the 8th option, n derivative, with respect to x, because we're plotting it with x. And we'll find our first line by clicking alpha, trace, selecting our first line. And we'll put x here. So this will be our velocity line. When time is equal to 2, we can click trace, select our red line by going down, and we'll select x is equal to 2. So when x is equal to 2, or when s prime of 2 is equal to negative 2.299 meters per second. Great. So we'll move on to part C. Determine the intervals of time when the particle is moving away from the point P. So this is when the particle is moving away. So we know that the particle is moving in a positive direction. So this will be whenever our velocity is greater than 0. To find out whether our velocity is greater than 0, we'll have to find the intercepts, or the x-intercepts of this red line. So we'll click trace, calculate, and we'll look for the 0 option. We'll go down to our left line. We can see it crosses the 0 and becomes negative here. So our left bound will be 0, and our right bound will be right after this line, and we'll find out where this is. So our first spot is from 0 all the way up to 0.433. So for part C, we have our first interval, which is from 0 all the way up to 0.433. And then we have a second interval, as we can see on this red line, of over here. So our next interval, when the red line crosses back into the positive, we can click trace or calculate, find the 0, and we'll go down to the red line and find out this first point where it crosses the x-axis. So the left bound will be here in the negatives, the right bound will be here in the positives. We'll find the 0, which is at 3.256. And we'll find the next one, the 0 of when we go back into the negative. So we're pretty much looking for the entire time this will be in the positives. So we'll cross back to our intercept here, and this is where it'll be 6.3396588. So we can round it to 6.340. These will be our 2 intervals of where the velocity is greater than 0. So this will be our answers. For part D, we want to find the value of B and the value of C. So the value of B in this top part, the acceleration of the particle is 0 when t is equal to b and t is equal to c, where b is less than c. So t is equal to b and t is equal to c, where b is less than c. The acceleration of the particle is 0. So the acceleration, or a of t, is just the same as v prime of t, or in other words, s double prime of t. So we'll go back, we'll make another line. We'll go back to math, find the derivative button, go back, find the derivative button, and we'll do with respect to x. This time we'll do v prime of t. So we'll select our second line. So y2, select x, and we'll graph this. So this black line is the acceleration line. So we want to find where the acceleration is equal to 0. So we can see 2 spots in our acceleration line where it crosses the x-axis. We'll trace. Similarly to the last question, we'll find our 0 for the black line. So make sure it's on the black line. Our left bound will be right before it crosses the x-axis. Our right bound will be right after it crosses the x-axis, and we get an x value of 1.231. So our b is equal to 1.231, and our c will be the next one. So we'll click trace, 0, and we'll look for the next time it crosses the x-axis, which is all the way over here. Make sure we're selecting the black line again. So right before it crosses and right after it crosses, and we select it. we get another c is equal to 5.690. This is our answer for part D. Finally, for part E, we want to find the total distance traveled by the particle for b is less than or equal to t is less than or equal to c. So to find the total distance, or in other words, area under this curve, we need to find the integral of the displacement. So we'll go into our math option. We'll select the 9th option, the integral from b is less than or equal to t is less than or equal to c. So our b is 1.231, our c is 5.690, and similarly, we want the total distance, so we'll go back to math and select the absolute function. And we will do this for the velocity to get the total, so our y2. So we'll go back to this. We'll select our y2 by going to alpha, trace, select our y2, and we will do d of x. There we go. So while this calculates, we finally get a total distance traveled as 19.56 meters. There we go. That's the answer for the last part of this question. Great job.